Welcome to my presentation. My name is Farzaneh Davari and I'm a PhD candidate in computational social science in George Mason University. Also, I teach a graduate level course of decision making in complex environment for public policy. I would like to present an agent-based model in which the policy of legally restricting farmers' access to water in order to force them to change their crop pattern is programmed. Obviously, it's a type of command and control policy. For this reason, the name of the model is command and control. The situation and the behavior rules has been extracted from the case study of Urmia Lake Basin in northwestern Iran. You can find the full description of the model, which follows the format of ODD plus D in the presented paper. However, in this presentation, because of the time limitation, I will go through an introduction of concept of command and control in natural resources and introducing Urmia Lake Basin case study in order to justify the model purpose. Then I will present the conceptual process of the model in order to explain the model that I'm going to demonstrate here. The model is programmed in NetLogo, and I think these are sufficient for starting discussions in the forum, and I'm looking very much forward to it. Central top-down policymaking, planning and management in natural resources has a long history and has been challenged theoretically as well as practically. According to Holland and Murphy, this approach has found its way to natural resource management when the population was increasing and natural resources were declining. Generally speaking, command and control is a linear cause-effect problem-solving approach, which assumes that there is a controllable solution to a well-defined problem. Applying command and control approach in a social ecological complex systems not only doesn't produce the expected outcomes, but also different issues will be emerged as the consequences of implementing command and control approach. Urmia Lake restoration policies in northwestern Iran follow the same command and control approach, even though the policymakers admit that Urmia Lake Basin is a social ecological complex system. Urmia Lake, which is the world's second largest hypersaline lake, started the drying process 4 decades ago. According to the Urmia Lake Restoration Program, this scientific studies indicates that extra water consumption in agriculture reduce the inflow of water to the lake. It was concluded that the consumption in agricultural sector should be reduced by 40% and the crop pattern should be changed from high water demand to low water demands crop. However, history shows that farmers don't follow the command and find their own way to get the amount of water that they need. This model addresses the policy of command to change the crop pattern and control water consumption by establishing special forces to control water consumption, which is called water police forces. This is an overview of the model process and scheduling. In the beginning of the cultivating season, each farmland is allocated to the specific amount of water which is sufficient for the low water demand crop. Farmer decision on crop pattern do not necessarily follow the allocated amount of water to the farmlands. Farmers' decisions are affected by their perceptions of their status, their neighbors' status, the availability of water sources, as well as their interactions with the water police. Farmers' crop type decision follows the decision-making path. As you see in this process, a farmer faces three types of final decision: cultivating the land with low water demand crop or high water demand crops, or leave the land uncultivated. In its sequential path, the first thing a farmer faces is to check its needs to extra water. If it doesn't need extra water, it decides to cultivate land with a low water demand crop. If the agent needs extra water for any reason, it checks if it has the capacity to seek extra water, because not everyone has the same capacity. If it does, the farmer also checks its neighbor's status for the security reason. If more than certain number of neighbors uh, cultivate high water demand crop, the farmer decides to move to the water sources to pick extra water. However, if the legal punishment law is in effect, the farmer agent also checks its records of being fined before deciding to move for seeking extra water. If the farmer agent is fined less than certain times, the farmer agent decides to move to take extra water. If the farmer who is moving to take extra water is not in the vision of the water police, who are moving around, the farmer agent picks the water and goes back to its farmlands and cultivate high water demand crop. If the farmer who is seeking extra water is catched by the water police, it goes back to its land and its status changes to the farmer with who is in need but has no capacity to seek extra water. If the farmer agent has no capacity to seek extra water but is in need of extra water, it checks its neighbors for the same situation. If the farmer has at least certain number of neighbors in the same situation, it decides to dig a well and cultivate high water demand crop if the water police cannot see the farmer digging the well. If the water police catches the farmer digging a well, the well will be filled up and the farmer will be returned to the farmland to decide to either cultivate its land with low water demand crop or leave the land uncultivated. Control model is programming net logo and the interface of the model. As you can see, the model is initialized by a random distribution of the artificial word to the water policy station, water resources, and number of farmlands, and the number of each agents. There are three agents, follows the global variables which are subject to change by users. The order of initialization are also subject for sensitive analysis that I applied all of them in my research. The farmlands that are into green and yellow, green and red ones actually are assigned to two crop types. The red one represents high water demand and the green represents low water demand crops. A small portion of farmland is allocated to low water demand crop because the program targets areas where high water demand crops pattern are dominant. The model results are all sensitive to this portion as well, should be analyzing sensitive analyzing. There are several the model is built on several submodels that I can show you in the code part. Farmer seeks surface water from river, police water catch farmer. Um, you can read farmer gets water, and but the important part is the number of police water increases and decreases based on the different strategies. There are three strategies modeled in this program in this model. The first one is the very extreme, that there is no tolerance of high water demand crop farmland. The second one is semi-extreme, but the third one is satisfactory, that there is a tolerance for high water demand crop based on the relationship of the water consumption of the low water demand and uncultivated, so it doesn't affect the amount of water that at the macro level can be used. As an output, as a system, actually the model observes crop pattern change and collect the information over time for high water demand, low water demand, and uncultivated land. Also, the number of police and number of farmers are changing, and the outputs are cumulative at the system level. There are water picked, wells closed, dried water, and farmers catch. Two other outputs that are unwanted consequences of the policy or dissatisfaction of farmers and their income loss. So income changes. This model that I'm demonstrating is based on a satisfactory policy. I put it in a fast. As you see, as the findings of the model, in the first step of the uh, presence of water police forces, the crop pattern changes from high water demand crop to low water demand, but it's not a sustainable policy. Indeed, it contributes to emerging the phenomena of dissatisfaction and a large number of farmers economically lost, which is actually unwanted consequences. But you never reach the number of amount to eliminate the high water demand crop. If I want to demonstrate the other model, other policy, which is a very extreme, you see that it changes to battlefield, but still, and the number of police increases and increases, even more than farmers. Sometimes it is more than three times, four times of farmers, number of farmers, but still the water is picked, the wells are closed, the farmers caught, and the dissatisfaction and income changes actually are high, but they never get to the zero high water demand water high water demand crops elimination. You see, is increasing. Thank you so much for your attention and looking forward to the discussion.